Let's get the ego check out of the way first. You know you're small, but you don't really know. Imagine the Earth is a grain of sand. If you held that grain of sand on your fingertip, the sun would be a billiard ball about 20 feet away. The nearest star, Proxima Centauri, that would be another billiard ball about 1,000 miles away. That's just the immediate neighborhood. The Milky Way galaxy, our city, is 100,000 light-years across. If you shrunk the entire solar system down to the size of a quarter, the Milky Way would be the size of the North American continent. And the Milky Way is just one of 2 trillion galaxies in the observable universe. You aren't just a needle in a haystack, you're an atom in a needle in a haystack the size of the ocean. Forget the dynamite visual. The Big Bang wasn't an explosion in space. It was an explosion of space. 13.8 billion years ago, everything, every book you've read, every person you've loved, every star in the sky, was crushed into a single point hot enough to melt logic. Then it expanded, fast. It didn't expand into room because there was no room outside of it. It created the room as it grew. It's still happening right now. The universe isn't sitting still. It's stretching. We are living in the aftershock of the beginning of time. Light is the cosmic speed cop. It moves at 186,282 miles per second. Nothing moves faster. This isn't just an engineering problem. It's a law of physics. Because light takes time to travel, looking at the sky is actually time travel. When you look at the moon, you see it as it was 1.3 seconds ago. The sun? 8 minutes ago. The nearest star? 4 years ago. If an alien 65 million light-years away looked at Earth right now with a super telescope, they wouldn't see us. They would see dinosaurs. The universe is a giant history book, and we are always reading the past. Isaac Newton thought gravity was a force like a magnet pulling you down. Einstein came along and said, "Nah, it's geometry." Imagine a trampoline. Put a bowling ball in the middle. The fabric curves, right? Now roll a marble past it. The marble curves around the bowling ball. That's an orbit. Mass bends space. The Earth bends the space around it, and the moon rolls along that curve. You are sticking to the floor right now not because Earth is grabbing you, but because you are sliding down the dimple Earth makes in the fabric of reality. Stars are just clouds of gas, mostly hydrogen, that got too heavy for their own good. Gravity crushed the gas together so hard that the atoms started smashing into each other and fusing. This fusion releases energy, a nuclear explosion. That's what a star is. A continuous, billions of years long nuclear explosion contained by its own gravity. It's a balancing act. Gravity wants to crush the star into a point. The nuclear explosion wants to blow it apart. They fight it out for billions of years. That fight creates the light and heat that keeps you alive. Our sun is a middle-aged, average star. It's about halfway through its life. It burns 600 million tons of hydrogen every second. It's big enough to fit 1.3 million Earths inside it. But it's moody. It has solar flares, burps of radiation that can knock out power grids on Earth. It has sunspots, cool patches larger than our entire planet. Without it, we are a frozen rock in the dark. With it, we get sunburns and photosynthesis. Respect the orb. We got lucky. We park our planet in the Goldilocks zone. Not too hot, not too cold. If we were 5% closer to the sun, our oceans would boil away like Venus. If we were 10% further out, we'd be a frozen wasteland like Mars. We also have a magnetic field. Deep underground, molten iron swirls around, turning the planet into a giant magnet. This shield deflects the nasty radiation from the sun. Without that invisible shield, the solar wind would have stripped away our atmosphere a long time ago. The moon isn't just a nightlight. It's our stabilizer. Earth wobbles as it spins. Without the moon, that wobble would be chaotic. The climate would swing wildly from ice ages to heat waves in just a few thousand years. The moon's gravity holds us steady. Also, it was likely born from violence. The leading theory is that a Mars-sized planet smashed into Earth billions of years ago. The debris splashed out and formed the moon. We are walking on the scene of a planetary crime. It's not just us and the sun. Mercury, a sun-scorched rock. Venus, a hell's cape of acid rain and crushing pressure. Earth, you are here. Mars, a rusty, dead desert that we are desperate to visit. Jupiter, the boss, a gas giant that shields us by sucking up stray asteroids. Saturn, the one with the bling rings. Uranus and Neptune, the ice giants, freezing and full of methane. And Pluto is still there, frozen and tiny, hanging out in the Kuiper belt with thousands of other icy rocks. When the solar system formed, not everything made it into a planet. The leftovers are asteroids and comets. Most asteroids hang out between Mars and Jupiter. Most comets hang out way, way back in the Oort cloud, a shell of ice surrounding the solar system. Sometimes they get knocked loose and come visit. If they're small, they're shooting stars. If they're big, well, ask the dinosaurs. We've found thousands of exoplanets. Some are hot Jupiters, gas giants orbiting so close to their stars they boil. Some are super Earths, rocky worlds twice our size. Some are water worlds, covered in oceans hundreds of miles deep. Statistically, almost every star you see at night has at least one planet. The sky is crowded. Nebulas are giant clouds of dust and gas. They are the most photogenic things in the universe. Some are stellar nurseries, where stars are born. Gravity pulls the dust together until it ignites. Some are planetary nebulas, where stars die. A star puffs off its outer layers, creating beautiful, colorful shells of gas. Basically, the universe recycles. The dead stuff becomes the new stuff. When a massive star runs out of fuel, the balancing act ends. Gravity wins instantly. The star collapses in on itself in a fraction of a second, then bounces off its own core and explodes. This explosion is so bright it can outshine an entire galaxy of billions of stars. Here's the cool part. The fusion inside stars creates elements like carbon and oxygen. But the heavy stuff, gold, silver, uranium, that's only created in the intense heat of a supernova. The gold in your jewelry was forged in the death of a giant star. If a star is really, really big, the supernova leaves behind something terrifying. The core collapses so tight that it punches a hole in reality. A black hole is an object with gravity so strong that not even light can escape. If you cross the event horizon, the point of no return, you are gone. If you fell in, you'd undergo spaghettification. The gravity at your feet would be so much stronger than at your head that you would be stretched into a long, thin noodle of atoms. Not a great way to go. If a star isn't quite big enough to become a black hole, it becomes a neutron star. Imagine taking the sun and crushing it down to the size of Manhattan. That's a neutron star. A single teaspoon of neutron star material would weigh about 6 billion tons. They spin incredibly fast, hundreds of times a second, blasting beams of radiation like a cosmic lighthouse. We call those pulsars. Stars don't like to be alone. They cluster in cities called galaxies. Galaxies come in shapes. Spirals, like ours. Flat disks with arms. Ellipticals, big, fuzzy footballs of old stars. Irregulars, messy blobs, usually because they crashed into another galaxy. Galaxies are held together by dark matter and usually have a supermassive black hole in the center. Our galaxy is a spiral. We live in the suburbs on a minor arm called the Orion Arm, about 26,000 light-years from downtown. If you look at the constellation Sagittarius, you are looking toward the center. There sits Sagittarius A, a supermassive black hole 4 million times heavier than the sun. Don't worry. We're safe here in the quiet suburbs. Here's where it gets weird. When we look at galaxies, they spin too fast. Based on the visible stars, they should fly apart. But they don't. Something invisible is holding them together. We call it dark matter. We can't see it, touch it, or bounce radar off it. We only know it's there because of its gravity. It makes up about 27% of the universe. The stuff we can see, atoms, stars, you, me, is only about 5%. We are the minority. If dark matter pulls things together, dark energy pushes them apart. The universe is expanding, but it's also accelerating. It's getting faster. Something is filling empty space and pushing galaxies away from each other. Dark energy makes up roughly 68% of the universe. We have absolutely no idea what it is. We just gave it a cool name so we don't feel stupid. Time is not constant. It's relative. The faster you move, the slower time passes for you. If you got in a spaceship and flew at 99% the speed of light for a year, you'd come back to Earth and find that decades had passed for everyone else. Gravity does this too. Time moves slower near heavy things. Your feet age slightly slower than your head because they are closer to the Earth. GPS satellites have to adjust their clocks because time runs faster for them up in orbit than it does for us on the ground. Is this the only universe? Maybe not. Some theories suggest our universe is just one bubble in a cosmic foam. Each bubble could have different physics. Maybe in another universe, gravity pushes instead of pulls. Maybe in another one, you are hearing this on Mars. We can't prove it yet, but the math suggests it's possible. There are billions of stars, billions of planets. The universe is 13.8 billion years old. Life should be everywhere. So where are they? That's the Fermi paradox. Maybe space is just too big. Maybe civilizations kill themselves off, nuclear war, climate change, before they get to space travel. Maybe we are the first. Or maybe they're watching and just staying quiet. This is the scary answer to the Fermi paradox. The great filter is the idea that there is some hurdle that life rarely gets past. Is the filter behind us? So we're lucky. Is the filter ahead of us? So we're in trouble. Space and time are woven together. You can't move through space without moving through time. Think of it like a coordinate system. Up, down, left, right, forward, backward. And duration. You are always traveling through space-time. Right now, you are sitting still in space, but hurtling forward in time. Relativity explains the big stuff. Quantum mechanics explains the small stuff. And they hate each other. In the quantum world, rules break. Particles can be in two places at once. They can teleport. They can be linked across the universe. It's chaotic and probabilistic. Einstein hated it. He said, "God does not play dice." Turns out the universe plays dice constantly. If you tune an old TV between channels, about 1% of that static is radiation left over from the Big Bang. We can take pictures of this radiation. It's called the cosmic microwave background. It's a heat map of the universe when it was just 380,000 years old. It shows us exactly where the matter was clumping up to form the first galaxies. It is the ultimate baby photo. How does it end? The leading theory is the heat death. Dark energy will keep pushing galaxies apart. Stars will burn out. New stars will stop forming. The universe will get darker, colder, and emptier. Eventually, even black holes will evaporate. The universe will become a cold soup of subatomic particles, stretching out forever in total darkness. Don't worry, this is trillions of years away. We are made of dead stars. The atoms in your right hand probably came from a different star than the atoms in your left hand. Life is the universe waking up and figuring itself out. Hydrogen gas, given enough time, turns into people. That is the wildest fact of all. You are the universe observing itself. In 1990, the Voyager 1 probe turned around and took a picture of Earth from 3.7 billion miles away. Earth appeared as a tiny speck of dust suspended in a sunbeam. The pale blue dot. Every king, every peasant, every war, every love story, every debt, Every moment of history happened on that pixel. Puts your bad day at work into perspective. We don't know what caused the Big Bang. Maybe our universe is the result of a black hole forming in another universe. Maybe universes are born and die in cycles. Science is about admitting what we don't know. We are apes on a wet rock, circling a mediocre star, trying to figure out the code of reality. We've learned a lot, but the street knowledge of the universe is infinite. Sleep tight. You're floating in a mystery. Thank you for listening. If you are still awake, please subscribe to our channel to continue listening to the unknowns.